Alright, so this is a continuation video of the graphene multi-layered cylindrical commutator. So I had finished explaining how the commutator is built. It's made out of graphene and dielectric. You have your shaft there. So I'm going to continue to explain the armature and external circuit side of the motor. So you have your second half of the hub and your first half, and here we have a graphene wire. You can make your graphene wire by taking a graphene sheet and cutting it in slices where it looks like zigzags, and then you can stretch out the sheet and coil it around create your wire. Or you could take copper tubing and pour in your graphene mold or your graphene liquid, and then seal the copper ends, and then you'll have your graphene coated wire, or graphene copper coated wire. There's different other ways you could do it. So continuing how this motor works out, you have your graphene wire. The reason I use graphene wire is so that you could put 11 times the amount of electricity, because graphene is 11 times more conductive than copper is. So we'll put 11 times the amount of electricity into the coils. So you have electricity running down the graphene. Your graphene has a coil of wire. It runs in a coil and then goes back to the commutator hub. You could use an electromagnet to make the magnetic field, or you could just use a large inductor and make a magnetic field. So in this one I'm just showing an inductor, so it's just graphene wire. This picture right here really doesn't have the shaft, but the shaft should just be in the middle of the commutator hub. And if you've seen in my other video how I have my multiple alternator motors and generators, you would just have multiple circuits. You'd have multiple coils of wire. So here's your power sources. You have the correct polarities, negative and positive, run down the wire, go to the brush side of the commutator, go to the correct contact layers. The negative energy goes out to the armature layer, or the armature side of the commutator.
You need that legs for you freaking idiots.
And so you have
you need those reviver seats. Yeah.
the electrical current going down into the graphene wire, which is coiled. So you should have a north on top and south on bottom. So you could have multiple wire, since you have multiple circuits in the hub. You got north on top and south on bottom. Then on the shaft you'll have one circuit on the shaft, and then your next circuit will be next to it, sitting right adjacent to it. And you have your four alternators, and all the norths will be on top and all the souths will be on bottom. So you have your polarity correct. And let me continue to think of what I'm going to say. They are all aligned, so, and they're in the same position, all the alternators, if you've seen my other videos. And if they would pass a horizontal line test and a vertical line test. Since they're all parallel and perpendicular, they're just basically adjacent to each other, so that's the only difference. So how does the motor turn and work? So over here I'll show you this diagram. You have negative on the bottom hub, you have the negative contact layer on the outside, and on your top of the hub you have your positive contact layer on the outside. So they're different. You notice the negative, positive layers on the bottom, and the positive, negative layers going outward, inward to the center of the commutator on the top of the commutator. So on your first turn, you have positive as your contact layer here, and your negative on the inside towards the inner side of the commutator hub. And so there would be one circuit where you connect your coil of graphene wire. So the positive would go to the coil of wire. So let's just say you have a positive on the outside and negative on the inside. So the way you put your coil, or which direction you put your coil, let's say it has north on top and south on bottom. So at first, your first 180 degree turn would have north on top and south on bottom. And as your commutator turns, your brushes are stationary, and the coils of wire, your external circuits, are just connected to the commutator and move with the commutator. So as the commutator moves, the brushes are stationary. So for your first 180 degree turn is going to have positive on the outside and negative on the inside. So you'll have north on top and south on bottom. Now your lower commutator hub has negative on the outside and positive on the inside. So when the commutator hub reaches past the 180 degree point, your external